All right. Hey, everybody. We're going to start with a review from last class. Draw each of the kinds of slope. I'm not looking for like the Mona Lisa here, just like a brief picture. A positive slope should be doing what? Going up, something like that. That's all I'm really looking for. Negative would be going down, decreasing, increasing, decreasing. We'll try and use good vocabulary. Zero, what would that look like? Horizontal, good. And then undefined is vertical. That's like a hill you couldn't walk up unless you had like suction cups on your feet or something. All right, this is exactly what you did in your homework. Find the slope of the line. You have to find 2 points that are exactly on nice, perfect numbers. So can someone shout out 1 to me? There's plenty on there, but let's just find 1. 1. Okay, I see that one. What else? 2, 3. If you picked different ones, that's fine. Look, they're everywhere. You could use any of those, all right? And I'm going to draw in the little triangle. That's what you had to do on your homework. Do we do the vertical part or the horizontal part first? Let's. Yes, good. Go up and then, and I try not to say over, try to say left or right, because it actually does make a difference. One's one way and one's the other. So we went up how much? 2 and then over 1. So it's 2 over 1, but you can just say 2. If you write 2 over 1, full credit, 100%, not taking off any credit for that. It means the exact same thing. Now this one says graph this line. So we want to go through this point. Let's review the quadrants. What quadrant is this point in? -1, 3. 2. This is the second quadrant. So you're going to go ahead and plot that. This is 1, 2, 3, 4. You start in the top right and then it goes counterclockwise. 1, 2, 3, 4. So that's your starting place. And then -4 fifths. You can put the negative with the 4 or with the 5. It doesn't matter. Using words like up, down, left, and right. Like what are our instructions to do this slope? What would we do? Down 4.
Left,
right 5. Good. So from this point, we're going to go down 4. Here, I'll draw in the triangle. We're going to go down 4 and then right 5. And the way you can check your work is if it's a negative slope, your line should be decreasing. So that's how you can make sure that you're right. Positive, it should be going up. Negative, it should be going down. That's what we covered last time. Are we all back to the same page? Because it's been 2 days since I've seen you. So of course we forgot everything, right?
Yeah.
I mean, I know how that works. What's that? All right, that's what we did last time. Now we're going to move forward. How could you get the slope from this line, but without the graph? Like if I took the graph away, how could you get the answer? That's what we're going to head towards today. If you don't have the graph, how could you still get the answer? Let's pick 2 points on the line to use. I'm just going to pick these 2 because they have positive numbers with them. So we're going to write down this point, 1, 1, and 2, 3. So pretend that's all you have. I'm going to slide this up so you can't even see it. That's all you're given. You don't have a graph. How could you still get the slope? Well, you want the distance vertically first. So using these points, how could we already know the answers 2 for that, but using these numbers, how would you end up with that vertical change? Like using these numbers. This change. Well, first of all, let's do this. Is it a change for X or is it a change for Y? It's a change for Y. So why don't you look at the Y parts of these points? Do you see which ones are the Y values? Good. Say that louder. Subtract them. You would subtract the Y values. So it would be 3 minus 1. That's how you're getting that difference. Remember, difference means subtraction. And then that's over. And now we're going to do the change for X because it's rise over run. Now we already know that the answer is 1 for this, but looking at the X numbers here, how would you get that mathematically? Yep, subtract them. It would be what minus what? 2 minus 1. And if you work that out, look at what's 3 minus 1, guys? 2. 2 minus 1 is 1. Oh my gosh. Okay, so I'm going to write out the formula for you and you have to know it. But that's why it works. That's where it comes from. you are going to subtract the y values and then put a fraction bar and then subtract the x values. That's like the process. That's writing it out in words. Now I'm going to write it out in the formula, which you have to know as well. And you have to let me know if you've seen this last year. I bet that you did. I'm willing to bet that you did. But that in essence is what you do. If you can subtract, you're going to be fine, which you all can. Okay. Subtract y, subtract x. Does anyone remember what letter stands for slope? And it kind of doesn't make any sense.
Like F or something. M or M, yeah.
It's M. M equals, and you subtract the y values. It's written like this, y2 minus y1. It just means subtract the y values. You take the y value from this point and the y value from this point and you subtract them. That's all it means. It looks nuts, but that's all it is, all right? Over, and then you want to subtract the x values, so x, bless you, x2 minus x1. This is the thing that you need to put stars and hearts and pictures of unicorns next to or something. You have to know that, like, you can't get through anything for the rest of this unit without that. But as I was trying to pull that out of you, it sounds like, did you see that before? Like you've seen that? You've seen M before, but not this part? Okay, cool, something new. You're gonna subtract the y values, subtract the x values. We're just gonna practice the heck out of it, okay? So it says, find the slope using the points and then graph it. The graph is kind of the way you can visually check. If you want to label your points, you can. Watch me do this and then write it down, okay? All the points are x, y. So if you want to write x, y for both of them, do that. Every point is x, y, x, y. It's always x, y. And then where the ones and twos come in, this is the first point, this is the second point. So if you want to put little ones on that first one and little twos on the second one, that's all that means. Point 1, point 2. And I'll write the formula big here on the board so that you can look back at it. You are just going to subtract y, put a fraction bar, and subtract x. Ready? M equals. What are your two y numbers? We labeled them, but I just want to ask you, shout them out to me. What are the y numbers? Okay, we're going to do 4 minus 7 and draw a fraction bar. If you can subtract, you're going to get it. That's all you have to do. Subtract the y values. So 4 minus 7. And then what are your x numbers? I know we labeled them, but I just want to make sure you're with me. Good. So down here, it's going to be -6 minus -4. Now we have those negatives to fight through, but obviously on a quiz or test, you'd have a calculator. You could always type it in, but let's just see what we get. We're going to do the numerator, then we're going to do the denominator. 4 minus 7 is -3. Down here, these negatives cancel. So it'll actually be +4. So -6 plus 4, say that louder, would be -2. And then what? Because we have one more step for the answer. -3 over -2. What happens to those two negatives? If you take a negative number and divide by a negative number, it's positive. So it's going to be 3 over 2. The way that the graph helps us check is the line should be going up, right? If it's a positive, if you get a positive answer, the line should be going up. It should go up 3, right 2. So that's how we're going to check our work. Plot these 2 points and connect them. That's all you got to do. What quadrant would -4, 7 be in? Think about it. Which one? 2. So we're going to plot -4, 7. That'll be right here. And then -6, 4 would also be in quadrant 2. It would be right here. So you plot those 2 points and connect them, and then you check your work. Is that graph going up 3, right 2? Here, I'll draw in the triangle. Does that look correct? You can count to 3 and count to 2, you're going to get it. Like, it's really not all that hard, okay? But it's new to you. Oh my gosh, something new to you. That's great. Let's try another one. We're just going to practice the heck out of it. Go ahead and label the points. They get labeled X, Y, X, Y, X, Y. And then the first one is 1. The second one is 2. 1s and 2s. So they're both x, y. This is 0.1, that's 0.2. Look back at the formula. Slope equals, m equals, you're gonna subtract the y values. All right, I'm gonna ask you this time. What's gonna go on the top? I asked you to shut that several times. What's gonna go on the top? Look at the formula, look at what we labeled. 5 minus 3 is perfect. And then on the bottom, 4 minus negative 2. And we're gonna have to deal with those negatives.
So the negatives cancel
Yeah.
outside this.
Okay, you guys are, you're good. Hold on, wait for me. Let's do the numerator. 5 minus 3 is 2. These will cancel and be positive. So 4 plus 2 is 6. We actually have one more step there though. 2 6 will actually be 1/3. Good. So the way that you check your work is you plot those 2 points, connect them, and what should your line be doing? Like this means it should go up 1 and to the right 3. Good. So just plot those points and make sure that's what it's doing. If it doesn't, you either had a mistake over here or you plotted your points wrong. But if you have a mistake, you'll catch it. So I plotted those 2 points. Is it going up 1, right 3?
No, it's going to.
It's going up 2, right 6, but if I go up 1, right 3, I'd get a point right here, wouldn't I? That's kind of like the point in the middle. And then if you go up 1, right 3 again, you can put as many points as you want. I kind of think you just go all the way to the edge, like up 1, right 3, up 1, right 3. I mean, if you can count to 1 and count to 3, you can get it. Like let your instincts kick in and just keep the pattern going. You have math instincts, whether you think you do or not, you do.
I disagree.
Let's try the next one.
Like the course is like-
Okay, go ahead and label these x, y, x, y. And then where am I going to put the 1s and 2s? Because they're both x, y. Where do the 1s go? The first one, and then 2s
For the second
on the
one,
second one. There you go.
if there's 3, you put 3s.
I will not give you 3. You only need 2 points to make a line. But in theory, yes, that would be x3, y3. And then if you had another point, it would be x4, y4. Yes, yes. And that's because it's rise over run. So the
So
vertical part,
horizontal.
yep. All right, so what's going to go in the numerator? Look back at your formula.
5 minus 5.
All right, 5 minus 5. And then in the denominator, subtract the x's. It will be 3 minus.
1. Just add 1.
Yeah, and a lot of people will get in the habit, if you see that, they'll just write +1, and that's fine. But what does this come out to in the numerator? It's 0 over 4.
Horizontal.
0, correct, but hold on, let me get everybody there. 0 divided by anything is 0. Again, on your quiz or test, you would have a calculator and you could type in 0 divided by 4 and it will tell you 0. Okay, so yes, it's a horizontal line. When you plot these, you should get a horizontal line. So -1, 5, 3, 5. And yes, look, we are correct because we're all geniuses. It's not too bad. The formula looks kind of scary when you first see it because it's like, oh my gosh, all these x's and y's and 1s and 2s, but you're just subtracting, so it's really not that bad. All right, so label this one, xy, xy. 1's on the first one, 2's on the second one. So what goes in the numerator? M equals, and then what goes in the numerator?
-2 minus 1.
Good, -2 minus 1. That's a lot of negatives, so we're going to be careful. And then in the denominator, it'll be -3 minus -4. Oh my gosh, that's a lot of negatives. Let's be really careful. And you do the numerator separately from the denominator. So if it's bothering you to look at, just like cover this up. All right, what's the numerator? -2 minus 1. Not 3, but -3. Good. So it'll be -3 in the numerator. And then down here, these negatives cancel. So it's -3 plus 4. So what will that give us? 1.
Put down 3.
Good, so down 3, right 1, this line should be decreasing, and you can leave it like that, or what else could you put? Yeah, just -3. I would accept either answer, that's totally fine. So plot those and make sure it's going down 3, right 1, down 3, right 1, because that's how you're checking your work. So just plot them and connect them. And then my suggestion is keep the pattern going, like let your instinct kick in and just keep the pattern going. The more points you put, the easier it is to make the line straight. Like if you only put 2 points on there, yeah, I get that that's hard, but if you keep the pattern going, it's easier to keep the line straight.
You have to draw the line.
Yes, yeah.
What if it's not true?
Then you fail. No, that's fine. I'm not grading your art skills. Just put points that go all the way to the edge and you'll be fine. Okay. I'm going to pause the recording. I want you to try this one with your partner, your group, whoever's near you, turn around, and then we'll go over it together. All right, let's see. What did you try putting in the numerator? It's 6 minus 0. And then down here would be -2 minus 1. Perfect. All right, so then do them separately. If it looks like too much, just cover it up. 6 minus 0 is just 6. -2 minus 1 would be -3. One more step though, 6 divided by -3. Yeah, and you can write -2 over 1 or just -2 is fine. Now that means when you plot this, what should the line be doing?
Going down.
Going down, down 2,
Not make negative.
right 1, down 2, right 1. So go ahead and plot this. Here's 1, 0. Here's -2, 6. Now, at first glance, it's not really down 2, right 1. Do you see that? Because we're like missing some points in between. But if you go down 2, right 1, down 2, right 1,
It does.
like they'll connect. Yeah. So you can do that to check your work and just keep the pattern going. It's really not like if you can count to 2, you can do it. I'm not asking for a whole lot there. Just keep going. Because then I don't have to answer the question. How many points do we have to plot? As many as fit. Just go to the edge of the graph. Every single time, just go to the edge of the graph. That's what I want to see. All right, and then last one of these. Go ahead and label X, Y, X, Y. First point is 1, second point is 2. All right, so M equals what's going to go in the numerator? Good. -5 minus 7. And then in the denominator, it'll be -2 minus -2, which if you went ahead and put +2, that's fine because the negatives are going to cancel out. Okay, hold on, because some of you are ahead of me. Do the numerator and denominator separately. What's the numerator going to give you? Be -12, thank you. Now down here, these cancel and it would be plus. -2 plus 2 be 0. Let's do a quick compare and contrast, and you have to listen to me on this because one is one way and one is the other. Do you see how this one gave us 0? 0 divided by anything is 0. This one doesn't give you 0. You are not allowed to divide by 0. This one's slope is what then? Undefined. Good. And you can just put UND.
If you just look at the problem, see if the same X is
Yes, and that's awesome. And I love that. Did you guys hear what he said?
Yeah.
If you look at this and you just go, hey, these are the same, it's going to be a vertical line, and you just put undefined, full credit, because that is, and it's not, gosh, you guys are so smart. Okay, now plot the points. What kind of a line should it be when we plot them?
Horizontal, vertical, yes.
Vertical.
Question, if we could do that with undefined, can we do that with horizontal?
Yes. So hold on, let me draw this and I'll go back to the other one and point to that. So look at number 4. If you just look at this and you notice the Y values are the same, and you're like, oh, that's going to be horizontal, and you just put 0, full credit. That's perfectly fine. I love it because that means you really understand what's going on. all right? But if you actually work it out, 0 in the numerator means 0, 0 in the denominator means undefined. And if you forget, when you type it into the calculator, it will tell you. This one will give you 0, this one will tell you an error of some sort, okay? So we just did finding the slope from 2 points. So if we've done slope from a graph, that's what we did last time. Just look at the graph and count the little boxes. We just did slope from 2 points. So that's using the little formula. Here we're gonna do slope from a table. It is the same. You are finding how y changes, and then you're finding how x changes. So let's look at y for the first one. Go ahead and close up. All you need to do is find the pattern. It's very instinctual, all right? -20, -23, -26, -29. What are you doing each time?
Subtracting 3.
Subtracting 3. You are subtracting 3 each time. Over, and then you're going to do the exact same thing for the x's. Just find the pattern. -2, -1, 0, 1. What are you? You are +1, adding 1. Now you could actually just leave it like that, but what else could you do? Like, how else could you write that? Yeah, just -3. Let's try another one. For number 9, look at the y values. 3, 8, 13, 18. What are you doing each time? You're adding 5 each time. I like these because it's just a pattern. And then for x's, 1, 4, 7, 10, you're adding 3 each time. Can you reduce 5 over 3? No, so just leave it. -8, 1, 10, 19. What are you doing? You're adding 9 each time. And then over here, -14, -11, -8, -5. How are you getting from one number? Adding 3. Good. It's confusing because they're all negative. Let's talk about that really quick. Do you see how they're becoming less and less negative? Okay. Does that reduce? It would be 3 over 1 or just 3. Case 4. We don't have that much else to do. Okay. All right. Number 11. 7, 7, 7, 7. What are you doing each time? Yet 0. And then for the x's, hold on. -5, -2, 1, 4, 3. Here's the $1 million question. Is that 0 or is that undefined? It is 0. It's horizontal. You're not allowed to divide by 0. When 0 is on the bottom, that's where you have the undefined issue. Okay. And if that messes you up, my calculus students struggle with that because 1 is one way and 1 is the other. So give yourself a break, but just try to remember 0 on the denominator is where you have the problem. All right. 52, 48, 44, 40. They're getting smaller, so we're subtracting 4. So -4. And then the x's. -6, -8, -10, -12. -2. Okay, couple of things there. First of all, the negatives
Cancel each other out.
cancel, so it's going to be +2. Good. And you just have to remember to do y first. -2, -3, -4, -5. You're minusing
-1.
1. And then over here, you're adding 2 each time. Does that reduce?
Yeah. No.
No. That's it. I like the tables. I feel like those ones are easy. Do we like those? You just remember to do y first, then x. That's really it.
There were 280.
All right. Here are some word problems. I also like the word problems because slope is really applicable and they're actually easier to understand. Slope is, let me put that away. Slope is rate of change. It is how quickly something is changing. Rate of change. And what word did I say you had to use? It's a really teensy tiny word when you're describing slope. Per. It is something per something else. So when it is a story problem, you need per. All right. There were two, do you know what an area code is?
Yes, 804.
Yeah, like ours is 804. Okay. Well, you understand that as the population increased, we needed more and more area codes. We used to not have so many. In fact, when I was a child, you didn't even dial a phone with an area code. You just picked it up and dialed the 7 digits. I know you're a dinosaur, Miss Cole. Anyway, as time has gone by, we've needed to create more area codes because there's more people and more phones. All right. So in 1999, there were 285 area codes. Now in 2020, there's 335 area codes. What's the rate of change? You have to figure out which one's X and which one's Y. So would you say area code per year, or would you say year per area code? You would say area code per year. The increase in area codes per year. So area code is the Y. Area code is going to be Y. Year is going to be X. Do you remember how it's Y over X? Coming with me on this? So that you don't get them backwards. It wouldn't make any sense to say year per area code. Okay, it's going to be area code per year. So if we write this as an ordered pair, it needs to be XY. So it's going to be year, which is 1999, comma, area code, which is 285. In 1999, there were 285 area codes. I Googled this. It's true. It's actually like real data. And then what's our other point going to be? 2022. 335. Yes, I'm not going to ask you to graph that. That would be very large numbers on your graph. Label the points. It's X, Y, X, Y. All points are X, Y. And then where do the 1s and 2s go?
1's on the left.
Yep. 1's on the first one, 2's on the second one. And we're just going to use our little formula. The numbers are large, so I'll pull up the calculator and we'll use that. It'll be 335 minus what? Oh, did I write it right? Yeah, 285. And then in the denominator, it'll be 2022 minus 1999. Hold on a second. Doesn't that logically make sense though? That's how much time passed. Do you get what I'm saying? Like if you take now minus then, that's how many years. Like, do you get that if you take now minus your birth year, you get your age? Like, okay, I just want to make sure it's like logically making sense for you. All right, so if we subtract those, 335 minus 285.
Wait.
That'll, what?
Think about it like this.
50.
Think about it like this. If we subtract 2022 from 8000 AD, what does that give us?
8,000 AD hasn't passed.
8000 BC.
We subtract 10,022. There's 8,000.
Can we talk about that once I'm not recording?
8,000.
I'll answer that question, but I just don't want it on this recording, if that's
8,000
okay.
BC is
All right.
8,000.
Shh. Does this reduce?
No.
No, because 23 is prime, right? Here, let's get a decimal though, because nobody talks like 50, 23rd. Let me divide that and we'll get a decimal. Let's say 2.2.
I don't want to.
So 2.2 area codes per year. So over that time, we gained roughly 2 area codes per year.
That's
They had to
not
keep adding them because there were more people.
Did we get 2.2 this year? Just 2 this year?
I don't know. It's an average. It's like on average. All right, and then the last one's a table. This represents how far a group of hikers was walking over time. What's their rate of change? All right, how much are we adding each time for their distance?
260.
I think I made it 260. So we're adding 260. Because 260 and 260 would be 520. Okay. And then how many minutes? 1, 2, 3, 4. So it's changing by
So they're
1.
walking
So it's 260 what? Something with a per in it.
260 per minute.
Feet per minute. Never make up the units They are in the problem, and it's especially nice when you have a table because it's literally right there. 260 feet per minute. So is that kind of slow?
That's kind of slow.
Kind of slow. Well, they're not hiking, they're just like strolling up the mountain.
But that's like a mile.
Well,
or
how do
like
you go about
20